So this is a version of the test that I used to give out. What I normally do with you guys in class is give you guys some time to practice the problem, and then once you've had an opportunity to try them, I go ahead and work them out and explain them as I work them out. So no different than if I were in class. I'd like you guys to pause the videos when I say to do so. Try to work the problems out before I work them out and give you the answer. None of this is new. This is all review. We should be able to do this without having to see it first. Before we take the test tomorrow, this is exactly what the test is going to look like, except for the numbers are going to be different. Just like on our last quiz that we took, the directions are going to say what the answer should be in, so pay attention to that before you pause and start. But go ahead and take a second, pause the video. So now that you've had an opportunity, hopefully, to work this out, first off, it's important to pay attention to directions. The first two you should put in slope-intercept form. The second two you should put in point-slope form. So they should look like this when you're all done. Now, regardless of what they should look like at the end, it's important that we pay attention to what we're given so that we can answer the question. So on number one, we have a point and a slope. So we're going to plug it into point slope and move it to slope intercept. So it's going to be y plus 2 is equal to 1/2 x minus 4. I'm going to distribute my 1/2. Y plus 2 equals 1/2 x minus 2. And then my last step is to subtract this 2 to the other side. So I get y equals 1/2 x minus 4. Next one, again, it's asking for an equation in slope-intercept. Before I can do an equation in slope-intercept, I need to find my slope. So I'm going to do 5 minus 3 and 0 minus -1. So I get 2 over 1, which is just a slope of 2. Then I can plug in a point. Y minus 3 is equal to 2 times the quantity x plus 1. We distribute the 2. Y minus 3 is equal to 2x plus 2. We add our 3 to the other side. We get y is equal to 2x plus 5. Now on this one, number 3, we should have a lot less time to spend because it just wants point slope. We have a point and a slope, so we can leave our answer y minus 1 equals -3 over 2 and then x minus 2. I don't need to distribute. I don't need to do anything else. If you read the directions carefully, again, if you go further, you probably lose a point on the test tomorrow because it says write your answer in point slope. Next one, same thing. We need to find a slope. So we have 9 minus -1 over 7 minus 2, which is 10 over 5, which is a slope of 2. So we can pick either point. We can put y plus 1 is equal to 2 times the quantity x minus 2. We could have just as easily done y minus 9 equals 2 times the quantity x minus 7. We stop there. That's the answer. We're done. Writing an equation in standard form. Again, pause. Take a second to try it first, then watch me do it. Hopefully you took some time to pause it. If not, do so now. But here's what standard form looks like. When we do this, again, it doesn't necessarily have to happen first, but first thing I'm going to do is I'm going to clear my fraction. So I have 2y minus 6 is equal to x plus 4. I'm going to move my 6 to the right. I'm going to subtract my x to the left, and I have -x plus 2y is equal to 10. But in standard form, we want that leading coefficient to be positive. So I'm going to distribute a negative through the entire equation, and this is what I should get for my answer. Again, that's the first page. It looks no different from the quiz we have already taken. So I'm going to go ahead and slide. Again, as we get to these chunks, take a second, pause, determine whether the relationship is parallel, perpendicular, or neither. Again, there should be work on some of these. You shouldn't just write a word and guess. That's a quick way to lose 3 points instead of 1 or 2 points on a test. Number 1, these are already in slope-intercept form. I can identify my slope. So the slope of my first line is -1/2. The slope of my second line is 2. and I spell incorrectly here, delete. Let's just put n. Okay, on the second one, y is equal to negative 6x plus 13. And then I have y is equal to positive 1 over 6x minus 14. Again, all I care about is negative 6 and positive 1 over 6. Those are negative reciprocals of each other, so those are perpendicular. The upside down t means perpendicular. The first equation is in slope-intercept form. The second equation, I need to subtract my 2x to the other side, so I have 5y equals negative 2x plus 15. I divide by 5, so my slopes are negative 2 over 5 and 5 over 2. Those are negative reciprocals of each other, so those again are perpendicular. To write an equation of a line, remember, all we care about is the slope, so pay attention to the slope. If you don't know what it is, find it, and then use it to do point slope basically on these two. So again, pause, take a second, and try it. So in this one, again, negative 2y equals negative x plus 10. We divide by negative 2, and I'm just going to stop there. All I care about is this slope. So it's negative 1 over negative 2. So my slope is positive 1/2. Notice the second equation's line is the same. If I want to be parallel to that, I keep the slope the same. If I want to be perpendicular to that, for the second one, I do the negative reciprocal. So I do the same exact work. Y minus 5 is equal to positive 1/2 times the quantity x plus 2. I distribute, so I have y minus 5 is equal to 1/2 x plus 1. I add the 5. So I have y equals 1/2 x plus 6. To be perpendicular, again, I want the slope, I want the point. So I have y plus 2 equals negative 2 times the quantity x minus 5. Distribute the 2. Y plus 2 equals negative 2x plus 10, subtract the 2, y equals negative 2x plus 8. So again, for the sake of time, these are going to be pretty quick. We discussed these pretty quickly in class, but you can already see there I kind of slid past the answer. We follow the kind of correlation of the dots. If they're all over the place, if they're tightly together and going in a certain direction, again, if it's going down from left to right, that's a negative correlation. If it's all over the place in the middle, that's no correlation. And if it's going up from left to right, that is a positive correlation. The other one that we didn't discuss at great length was this one. Again, this is going to be very similar on the test that I give you. If you're given a table of values from a scatter plot, it doesn't matter what the picture looks like. Here is our M. Here is our B, and if it says right and round to the nearest tenth, there's what we look at for tenth. So it's 14.1 and negative 92.8, and that's all we do for our line. We just write a line equation, y equals mx plus b. So that's all we have for those. We don't have a ton. Now, the positive or negative correlation, you guys, what we look at is this value right here. If it's really close to positive 1, it's going to be a positive correlation. If it's really close to negative 1, so if it was like negative 0.9562, that would be a negative correlation. If it's not close to either, it would be like 0.624. These numbers need to be really, really close to 1 or negative 1. Otherwise, your answer is just no correlation. But these numbers pop up in here when we're doing our problems. Okay? Please take the time to find the inverse of these functions, you guys. I'm going to have the work and answers there for you. But for the sake of the video running long, I'm going to not work them out step by step. But the steps are in our notes. Remember, the steps are right at y equals, and then flip the x and the y, and then re-isolate the y. And that's it. That's how you write the inverse of a function. So again, take the time to pause before you just scroll through and look at the answers, because you will have 3 very similar to this on your test tomorrow. We should not have a hard time isolating a variable and moving around functions at this point. All right, so hopefully we took some time, but here's what we end up with in those answers, just real briefly. So like I said, we write y equals instead of f of x equals. We flip the y and the x. We re-isolate. When I subtracted this 3 over, I left it over here, and then I multiplied that 2 off the bottom to this side. And again, y is over here. It doesn't matter. We can move it to this side and then rewrite it as the inverse of the function. Same thing on 16, we wrote y equals, we flip the x and the y, we re-isolate. So that's subtracting the 9 to the other side, dividing everything by 3 looks like this, and then rewriting it in inverse function notation. Same thing, y equals, flip the x and the y, add the 14 to the other side in this step, divide everything by 2 in this step, and we're done. So almost the entire chapter, you guys, if you kind of notice the pattern here, was just manipulating linear function using properties of algebra. So we can manipulate from slope-intercept or from point slope to slope-intercept. We can leave it in point slope. We can go from point slope to standard or from slope-intercept to standard. It shouldn't really matter. It's all the same process of just moving variables around and trying to make them look different and understand the parts of them. We'll use these skills as we go through the rest of the year. Make sure you take the time to study this, study your notes. Good luck on the test tomorrow. See you then.